Alright, the next question states graph each function and state its domain and range. So these are radical graphs, so you can put everything into your calculator. Just make sure that when you put this in your calculator that you have parentheses around the x minus 3 and around the x minus 3. So when you put this in your calculator, remember, we like to see a little table of values. Make sure you use at least about 3 points in your table so that it'll give you a nice graph. You'll notice when you put this in that you'll see some error messages. That means that the graph cannot go past certain numbers. So I am using 3, 5, 4, 6, and 7, 7. Now these graphs are not given to you in your review packet, so you might want to graph this on a separate sheet of paper so you have room. Okay, so I'm going to go to 3, 5, 4, 6, and 7, 7. So you notice that it's basically a half of a parabola on its side. So to find the domain, you notice that domain goes from left to right. Well, the first point that we have here is 3. There are no points to the left of 3, but there are points that go to the right of 3, increasing. So we say that our domain starts at 3 with a bracket because it's a definite stopping point. We're not going through 3, but we're stopping at 3, and then it proceeds to infinity. For the range, remember, range goes up and down, so there are no values that are lower than 5. But there are values that go higher than 5. So we say that we start at 5 with a bracket and go to infinity. The next thing you want to do is put in the next one in your calculator. And when you put this in your calculator, make sure you use math number 4 because this is a third root. Make sure that the x and the plus 5 are both in parentheses. And get yourself a nice table of values to use. We usually use about 5 numbers for these types of graphs, so it gives us a nice curve. But because the graph is kind of big, I'm only going to be able to use about 4 numbers. -6, -1, -5, 0, -4, 1, and I can use 3, 2. Okay, so we plot all of these points. And it's going to kind of look like an S on its side. If you notice, we have arrows going in both directions. So because those arrows are going in both directions, our domain goes all the way to the left and all the way to the right. So we say that our domain goes from negative infinity to positive infinity. There are no stopping points because of those arrows. The range also never stops as we go all the way down and as we go up. So the range is also negative infinity to positive infinity.